In this example, we're going to multiply two rational functions together. If you take a look at the top and the bottom of each one of those fractions, there's no addition or no subtraction in there anywhere. What that means is we can multiply and then reduce, or reduce and then multiply to come up with our final answer. I'm going to multiply first and then reduce at the end. So I'm going to multiply across the top and across the bottom and get our answer for the top and the bottom. So I have this single term here in the top and a single term here. Because there's no addition or subtraction, I'm just going to multiply the numbers together and then multiply the variables, the corresponding variables together in alphabetical order. I have an x to the fifth here. I can multiply that by my x to the third, and when you're multiplying things that have the same base, you add the exponents. So that would give me an x to the eighth power. Do the same thing with my y values. Y to the third times y to the fourth would give me y to the seventh when I add those exponents together. Doing the same thing on the bottom, I have a single term here and a single term here. Again, no addition or subtraction, so I'm just going to multiply my numbers together and my x's and my y's. Because there's no addition or subtraction in this problem, we don't have to do any factoring to simplify. What I can do in the next step is just reduce this fraction, starting with our numbers. This is just like the fraction 30/18. If you reduce the fraction 30/18 and take that common factor of 6 out of there, that leaves you with a 5/3. Then from there, we can evaluate our x values. We have x to the eighth over x to the fifth. When you're dividing like bases, you subtract the exponents. And 8 minus 5 is 3, so we're going to have an x to the third. And I'm going to put that in the top part of our fraction because there were more x's up in the top. That's where the higher exponent was. So when I write in our x to the third for our final answer, that's going to go in the top. Similarly with our y values, we're dividing like bases, so I'm going to subtract the exponents. I'm going to do the bigger one minus the smaller one. That's 12 minus 7, which is 5. So there's going to be a y to the fifth in our final answer, and I'm going to put that in the bottom because we had more y values in the bottom. That was y to the 12th. That was our bigger exponent, so a y to the fifth. And that is our final answer on that problem. When there's no addition or subtraction in the problem, you don't have to worry about factoring. You can just multiply straight across the top, straight across the bottom, and then reduce your fraction. For letter B, this is the same type of problem, except I do have some subtraction here, so I do need to go through and factor the top and the bottom of each fraction before I can do any reducing. The top of the first fraction, we have an x minus 3. That is in standard form. There's nothing in common with those terms. I have two terms there, but it doesn't fit any of our two-term patterns, so x minus 3 is not factorable. Not a bad idea to put that in parentheses just to remind yourself that because of that subtraction, either the x minus 3 cancels out as an entirety, or it does not. We can't just do the x or just the 3. On the bottom of this first fraction, I have 4x minus 20. There's a common factor of 4 there. If I factor that out in front, I do get an x minus 5, and that doesn't factor anymore. The top of the second fraction is an x minus 5, which does not factor. The bottom of that second fraction is an x squared minus 9. That is a difference of squares pattern. X squared is a perfect square because x times x gives us x squared, so we have x's for our first terms. Similarly, 3 times 3 is 9. That's why 9 is a perfect square, so we're ending with 3's, and then we need alternating signs. One of those would need to be a plus and one would be a minus. Now, if you look outside the parentheses, we don't have any addition or subtraction outside the parentheses, so now we can go through and reduce. When you reduce, if you have something in parentheses on the top of a fraction and on the bottom of a fraction, whether they're the same fraction or a different fraction, you can cancel those out. So this x minus 3 here and the x minus 3 on the bottom of the other fraction, those would cancel. Same thing with the x minus 5s here, they match exactly. When you cancel those out, remember they really don't disappear, they're really ones. X minus 3 divided by x minus 3 is really 1, so we really get ones there when we cancel those out. So on the top, everything canceled. It doesn't mean there's nothing there. It's a 1 times 1, really. So we have 1 in the top of our final answer, and what we have left in the bottom is a 4 and an x plus 3. It wouldn't be wrong to distribute that 4 in, but it is an extra step. It is preferred to have your answer in a factored form rather than multiplying that out and getting rid of the parentheses.